Introduction. Algebra is a branch of mathematics that involves letters for numbers. The numbers are the constants. The letters used are called variables. An expression contains the combination of constants, variables together with the arithmetic operators. When two expressions are equated together, we get an equation. Some equations are true for all the values, and such equations are called identities. Objectives. At the end of this lesson, you'll be able to identify the algebraic expressions, solve degree of polynomial, solve monomials, binomials, and polynomials, identify like and unlike terms, solve addition, subtraction, and multiplication of the algebraic expressions, describe identity and standard identities. What are expressions? The price of a chocolate is ₹5 and the price of a pen is ₹10. What is the total price of 3 chocolates and 10 pens? To solve their problem, we form an expression as cost of 1 pen is equal to ₹X. Cost of 1 chocolate is equal to ₹Y. Cost of 3 chocolates is equal to ₹3Y. Cost of 10 pen is equal to ₹10X. Total cost is equal to 3X plus 10Y, which is equal to 3 into 5 plus 10 into 10, which is equal to 15 plus 100, which equals 115. Total cost is equal to 115 rupees. Number line and an expression. Consider the expression x plus 4. Let us consider the variable x takes the position x on the number line. Since the given expression, the constant 4 takes the positive value, a takes the position 4 units to the right of x. If the expression is x minus 4, the position a will be to the left of x. Consider the expression 5x plus 6. Let x take the position x on the number line. Since the first term of the given expression is 5x, the position of 5x will be point D. The distance of D from the origin will be 5 times the distance of x from the origin. Therefore, the position of E of 5x plus 6 will be 6 units to the right of D. Algebraic expressions. Constants. A symbol having a fixed numerical value is called a constant. Example, 3 minus 5, 9 upon 7, p, etc. Variable. A symbol or alphabet which takes on various numerical values is known as variable. Example, circumference of a circle C is equal to 2pr, where r is radius of the circle, 2p constants cr. Variables. Algebraic expressions. A combination of constants and variables connected by plus, minus, x, and y is known as algebraic expressions. Terms. The several parts of the expression separated by plus or minus sign are called the terms of the expression. Example, 2 plus 5x minus 8x square y plus 1 upon 5 xy square is an expression containing 4 terms. They are 2, 5x minus x square y and 1 upon 5 xy square. Degree of a polynomial. The highest power of any term in the polynomial is called degree of a polynomial. Based on the degree, the polynomial are classified as linear polynomial, quadratic polynomial, cubic polynomial, biquadratic polynomial, etc. Linear polynomial. A polynomial of degree 1 is called a linear polynomial. Example, 3 plus 7 upon 5x. Here x is of degree 1, therefore it is a linear polynomial. Quadratic polynomial. A polynomial of degree 2 is called a quadratic polynomial. Example, x squared minus 4x plus 4. Here x of degree 2, therefore it is called as quadratic polynomial. Cubic polynomial. A polynomial of degree 3 is called a cubic polynomial. Example, x cubed minus 3x squared plus 5x plus 1. Here x of degree 3, therefore it is a cubic polynomial. Biquadratic polynomial. A polynomial of degree 4 is called a biquadratic polynomial. Example, 2 minus 5x plus x squared minus 8x raised to the power 4. Here x is of degree 4, then it is biquadratic polynomial. Degree of a polynomial in 2 or more variables. In the case of polynomials in more than one variable, the sum of the powers of the variables in each term is taken up, and the highest sum so obtained is called the degree of the polynomial. Example, 5x squared y cubed minus 3xy squared plus 6 minus square root 2x raised to the power 4 is a polynomial of degree 5 in x and y. Monomials, binomials, and polynomials. Based on the number of terms of the polynomial, they are classified as monomial, binomial, trinomial, and so on. Monomial. A polynomial is said to be a monomial if it contains one term. Example, Harry is having 7 roses, then it is denoted by 7x. Here, 7x is a monomial. Binomial. A polynomial is said to be a binomial if it contains 2 terms. Example, Harry is having 9 roses and 5 jellies. Then we form an algebraic expression as 9x plus 5y. X denotes number of roses, y denotes the number of jellies. 9x plus 5y is a polynomial which contains 2 terms. Trinomial. A polynomial is said to be a trinomial if it contains 3 terms. For example, Harry is having 8 roses, 6 jellies, and 5 chocolate, then the algebraic expression is given by 8x plus 6y plus 5z. Here x denotes number of roses, y denotes number of jellies, z denotes number of chocolates. 8x plus 6y plus 5z is a trinomial which contains 3 terms. Polynomial. In general, if the expression contains 1 or more terms whose coefficient is non-zero, then it is called a polynomial. Example, 4x plus 4xy plus 17xz squared minus 10y squared z plus 19. Multiplying a binomial by a trinomial. In this multiplication, we shall have to multiply each of the 3 terms in the trinomial by each of the 2 terms in the binomial. A plus 4 into a squared plus 5a plus 7 is equal to a into a squared plus 5a plus 7 plus 4 into a squared plus 5a plus 7, which is equal to a cubed plus 5a squared plus 7a plus 4a squared plus 20a plus 28, which equals a cubed plus 9a squared plus 27a plus 28. Example, simplify a plus c into 2a minus 3b plus c minus 5a minus 2b into c. Solution. A plus c into 2a minus 3b plus c is equal to a into 2a minus 3b plus c plus c into 2a minus 3b plus c is equal to 2a squared minus 3ab plus ac plus 2ac minus 3bc plus c squared, which equals 2a squared minus 3ab plus 3ac minus 3bc plus c square. 5a minus 2b into c is equal to 5ac minus 2bc. Therefore, a plus c into 2a minus 3b plus c plus 5a minus 2b into c is equal to 2a square plus 8ac minus 5bc minus 3ab plus c square. Identity. What is an identity? Consider the equality a plus 5 into a plus 3 is equal to a square plus 8a plus 15. We shall evaluate both sides of this equality for some value of a. Say a is equal to 10. For a is equal to 10, LHS is equal to a plus 5 into a plus 3 is equal to 10 plus 5 into 10 plus 3, which equals 15 into 13, which is equal to 195. RHS is equal to a square plus 8a plus 15, which equals 10 square plus 80 plus 15 is equal to 195. The values of the two sides of the equality are equal for a is equal to 10. Let us now take a as minus 1. LHS is equal to minus 1 plus 5 into minus 1 plus 3 is equal to 4 into 2 is equal to 8. RHS is equal to minus 1 square plus 8 into minus 1 plus 15 is equal to 1 minus 8 plus 15 is equal to 16 minus 8 is equal to 8. For a is equal to minus 1, LHS is equal to RHS. We shall find that for any value of a, LHS is equal to RHS. Such an equality, which is true for every value of the variable in it, is called an identity. Thus, a plus 5 into a plus 3 is equal to a square plus 8a plus 15 is an identity. Equation. An equation is true for only certain values of the variables in it. It is not true for all values of the variable. A square plus 8a plus 15 is equal to 195 is true for a is equal to 10, but it is not true for a is equal to minus 1 or a is equal to 0, etc. Summary. Let us summarize what we have learned. A combination of constants and variables connected by plus, minus, x and y is known as algebraic expression. A symbol having a fixed numerical value is called a constant. A symbol which takes on various numerical value is known as variable. Terms are added to form expressions. Expressions containing exactly 1, 2, and 3 terms are called monomial, binomial, and trinomial respectively. An algebraic expression in which the variables involved have only non-negative integral powers is called a polynomial. Like terms one formed from the same variables and the powers of these variables are the same. Coefficients of like terms need not be the same. While adding polynomial, arrange the like terms, unlike terms separately and add the like terms only. The same rule is followed for subtraction also. For multiplication,